So yes, let's start with our problem solving of the NEET 2025 paper. Here is the first question. And this question we have already discussed elaborately and we have done a video on this. You can check out that video. In this video, we are not discussing this question that elaborate. We are going to make it crisp and short. Okay, so here is the first question where we have this water tank. It has one wall at x equal to L and can be taken to be very wide in the z direction. When filled with a liquid of surface tension S and density rho, the liquid surface make angle theta naught, right? Theta naught is very much less than 1 with the x-axis at x equal to L. If y of x is the height of the surface, what is the equation for y of x is the question. Okay, so here, how we have to solve this? See, if we consider the water tank at x equal to 0, this is x equal to 0, and this is x equal to L, which where we are having actually a wall. At x equal to 0, is it a wall? No, it is not a wall. That's what the major point is. So you have the water because of surface tension. Basically, what will happen? It is pulled up, right? The surface tension actually pulls this liquid up against this wall, right? So if we are marking the surface tension like this, it is given this is theta naught basically. Now, how long this will extend to the left? There is no wall to the left we are taking. There is no such a thing told in the question. So let's assume there is no wall to the left. So this will continue. How long this will continue? Up till infinity, where you can take like the height of the liquid column. Maybe at infinity, you can take it as what? 0, we can actually take. Let's consider these 2 points B and C. Okay, so it is the surface tension that is actually pulling this liquid up. So basically, the pressure difference between the 2 points just above and below the point C, you can write it as equal to what? Y rho G, where Y is the height of the liquid column above the point B, right? Right? And the rho is the density of the liquid, and G is the acceleration due to gravity. Here, what is the thing? The pressure difference between the points just above and below the point C, that is actually balanced by what? The pressure due to Y column of the liquid, right? So here we have delta P in one way. Now, in one more way, we can write this pressure difference. How you can write this at the point C, if I'm writing in terms of radius of curvature and surface tension, you can write this relation. How is that? S into 1 by R1 plus 1 by R2, we can actually write. So if we have the tank like this, right? The liquid column is like this. You have this is the x-axis, this is suppose the z-axis, and this is the y-axis. If you are taking here R1, you can write it as equal to what? Rx. Let's say it is R. R2, you can write it as equal to what? Rz. And what is that equal to? Infinity you have to actually take because the tank is essentially wide along the z plane. There is no curvature there you can take. So obviously our pressure difference here become delta Pc, that will be equal to what? S into 1 by R plus 1 by infinity. 1 by infinity, we know it is 0. So obviously this will be what? 1 by S by R is what you'll be getting, right? So now what we do, this pressure difference that we are having, right? This S by R, you can connect it with the curvature. How you can connect it? Curvature is inversely proportional to the radius. Curvature is equal to 1 by radius, you can write. So you can write this as what? S into K, right? Now the rate at which the slope changes, slope of this meniscus if you are taking, slope if you are drawing at a point. That slope at what rate it changes with respect to distance. Basically, you can write that as what the curvature. So we can write this as what S into uh, y double dash, right? So here y double dash we can actually write here, right? So this will become S into d square y divided by dx square. Hmm. So where we have used actually the uh, curvature is actually proportional to what? Y double dash in this particular case. So now if we club these two together, we can write delta PC, that is equal to what? S into d square y divided by dx square, and that is equal to what? Y rho g we can write, or d square y divided by dx square, that is equal to rho g by s into y. And that is our answer for this question, where option number 2, which is d square y divided by dx square, which is equal to rho g by s into y, is the answer for this. Let's go for the next question now. So here is our second question. A microscope has an objective focal length 2 centimeter, eyepiece of focal length 4 centimeter, and tube length of 40 centimeter. If the distance of distinction of eye is 25 centimeter, what is the magnification of the microscope? This is quite rather a really straightforward question, a direct question basically. Now, what is the relation for magnification of a compound microscope that we are having? We have magnification M is equal to what? In terms of the length of the tube, we have the relation, right? What is that? L by FO into D by FE, where L is the length of the tube. The length of the tube length is given how much it is? 40 centimeter. We have the focal length of the objective. How much is the objective focal length? It is 2 centimeter. And we have the focal length of eyepiece. How much is the focal length of eyepiece? 4 centimeter. And we have the least distance of distinct division, which is nothing but what? 25 centimeter. What we have to do? We have to directly substitute the values. And what we are going to get? You're going to get 40 divided by 2 into D is 25 divided by 4. So how do you simplify this? So here we can see this. This is 10. And if you cancel this 5, 525s are 125. And 125 will be the answer. Option 2 will be the correct answer for this. So let's see the third question. An electron, mass is given, charge is given, moving with a speed c by 100, where c is the speed of light, is injected into a magnetic field B of magnitude 9 into 10 to the power minus 4 Tesla, perpendicular to its direction of motion. We wish to apply a uniform electric field together with a magnetic field so that electron does not deflect from its path. Then speed of light is given 3 into 10 to the power 8. Which out of these is the option is what you need to see. What must be the magnitude of the electric field that it must be, and also what is the direction, at what direction will be that you will be applying this electric field, right? So what is the concept behind this? This is simply the case of velocity selector only, right? What is the case of velocity selector? See, if suppose a charged particle Q, right, it is moving at a v velocity, right? If perpendicular to this, if you are applying a magnetic field, right? If this is a positively charged particle, you know that it experiences a force, okay, magnetic force in the upward direction, right? V cross B, V cross B. If you take it, will be in the upward direction. Uh, this charged particle will be experiencing a force. Now, for example, since it is a charged particle, if I apply an electric field vertically downwards, right? An electric field you apply in this direction. Because it is positively charged particle, it experiences a force, electric force downwards, right? So the magnetic force and the electric force are in the opposite directions. Now, if these two are equal, Fe and Fb, they are equal in magnitude, right? The net force experienced by the charged particle will be zero, and it experience uh, no deviation basically, okay? Without any deviation, it will be passing through. So that is actually the crux of this question. Okay, and from this, basically, we can find we have the relation for the velocity selected, the velocity of the charged particle for it not to be getting deflected, right? What is that relation? V is equal to what? E by B relation. Basically, it comes from this, right? QE is equal to QVB. If you solve this, you're going to get this, right? So V is equal to what? E by B relation. So E is equal to what? B into V. Correct. So here B is given. How much is the magnetic field given? 9 into 10 to the power minus 4 into what is C here? C is given, sorry, velocity is given as what? C by, I think, yeah, C by 100 it is given. C by 100, right? Where C is 3 into 10 to the power 8. So 3 into 10 to the power 8, right? C is 3 into 10 to the power 8 divided by 100. So what you are going to get here? 3 nines are 27 into 10 to the power 8 minus 2, which will be 6, and 6 minus 4, you're going to get what? 2, 10 to the power 2. So 27 into 10 to the power 2 volt per meter is what you're going to get the magnitude of electric field, right? So here you can see in these two options, you have 27 into 10 to the power 2. But how are you going to apply the magnetic field? E is parallel to B or E is perpendicular to B. Here we have the relation E is actually perpendicular to B, right? B is actually perpendicular into the field. We are applying cross the electric and magnetic field. So the answer for this will be what? E is perpendicular to B and its magnitude is 27 into 10 to the power 2. So here we are having the fourth question. There are two inclined surfaces of equal length and of same angle of inclination 45 degree with the horizontal. One of them is rough and the other is perfectly smooth. A given body takes 2 times as much time to slide down on rough surface than on the smooth surface. The coefficient of kinetic friction between the object and the rough surface, how much is close to? That's what we need to find. Okay, so what we are having here in this situation, so we have a rough surface and a smooth surface, right? So this is basically the rough surface that I'm going to denote, and this is the smooth surface that I'm going to denote, right? Both are having angle of inclination 45 degree on, right? And obviously, we have the time relation it is given, right? On the rough, it is taking more time. And what is the relation? The time taken to slide on the rough surface is twice as much as that on the smooth surface, right? So here, what we are going to use, we are going to use the time of slide in the case of smooth, right? And rough inclined plane. Separately, we are going to apply, right? What is the relation? In the case of smooth, you can write actually root 2L divided by G sine theta because the acceleration down the incline, right? In the case of smooth surfaces, G sine theta that you'll be getting. Okay, where we got it by applying the first, the equation of motion directly, right? And in the case of rough inclined plane, you can take the time taken will be equal to what? Because the acceleration will be different, right? So you'll be getting 2L divided by G into sine theta minus mu k cos theta. This is the relation that you'll be applying in the case of rough inclined plane. Okay, so these two will apply directly in our problem here. So what you're going to get with angle, I'm going to substitute the relation. So you'll be getting what? Root over 2L divided by G into sine 45, right? Sine 45 minus mu k cos 45, correct? And that is equal to what? 2 into root over 2L divided by G sine 45, we can actually write. So sine 45 and cos 45 both are actually 1 by root 2 only, correct? And if I take, suppose, square root, square on both the sides, if you are going to take this root, you can actually remove, right? And the things that are coming on both the sides, you can see here, 2L, G, all these things you can cancel. So you'll be getting 1 by, sine 45 is 1 by root 2 minus mu k by root 2, correct? Cos 45 is again 1 by root 2 only. This is equal to 2 square is 4 divided by 1 by root 2, obviously you'll be getting. Now here on the left hand side, 1 by root 2, you take it common outside. So you get 1 minus mu k, right? 1 by root 2, you took it outside. That is equal to 4 by 1 by root 2. What you can do, this 1 by root 2 and this 1 by root 2, we can cancel obviously. And you'll be getting here what? This 1 minus mu k. You are taking reciprocal now. What will that be equal to? 1 by 4 is what you're going to get. So now we need mu k. So mu k I'm taking to the right hand side, 1 by 4 I'm bringing to the left hand side, right? So 1 minus 1 by 4, which is 3 by 4 is what you're going to get. Okay, so obviously 3 by 4 is nothing but what? 0.75. And that's what the answer for this question. What is it? 0.75. And that is the answer. And then here is the fifth question. The kinetic energy of two similar cars A and B are 100 joules, 225 joules respectively on applying brakes. Car A stops after 1000 meter and car B stops after 1500 meter. If FA and FB are the force applied by the brakes on cars A and B respectively, what is the ratio of FA by FB is what you need to find, right? So you are applying this opposing force FA and FB on these two cars, right? So that basically these two cars will stop. Okay, what we are going to apply here? Simple. The work done, we have the relation, right? We have the work done relation. What is that? Work done is equal to what? Change in kinetic energy. Work is equal to what? Change in kinetic energy. That's what the relation we are using here. Okay, and we know if F is the force, the work done is actually equal to what? Force into displacement relation also we can use, right? So in this case, if you can write finally basically these two cars are coming to rest, right? So kinetic energy work done is equal to changing kinetic energy when you apply, right? Final kinetic energy will be obviously zero. And the work done by this opposing force will be negative, right? So zero minus that kinetic energy, okay, and these two negatives get actually cancelled. So in the first case of A, right? In the case of A, you can write FA into XA, correct? The distances traveled, FA into XA. You can write it as equal to what? Changing kinetic energy of car A. And in the second case, FB into XB, you can write it as equal to what? Changing kinetic energy of, or initial kinetic energy of B. Because 0 minus this sum we are going to take, right? So like this, we can actually write. So obviously now we can apply the values. What is it? FA into what is the distance traveled by the first car? It is given A travels 1000 meters. So 1000, right? That is equal to initial kinetic energy of these two cars are given. A is 100 joules. So you can write 100. And FB into what is this? 1500. So 1500. That is equal to what? FB. How much is that equal to? 225. We can write. So obviously it is very clear now. FA by FB when you're taking, it is nothing but you've taken the ratio of these two equations. So 100 divided by 225, right? 1500 will go the other side. 1500 divided by 1000. Okay, how do we simplify this? These two zeros will go, yeah, like this. 15 into 15 is basically 225, and you are going to get 10 by 15, which you can write it as what? 5 will go in both 2 by 3. So your answer will be what? 2 by 3 will be the answer. Again, option 2 will be the answer for this. So let's see the sixth question now. The current passing through the battery in the given circuit, how much is it? The question, right? So even though we have a in So let's see our next question. The current passing through the battery in the given circuit, what it is. So here we know this. If you to find the current passing from the battery, the potential divided by the equivalent resistance of the circuit. That's what we need to do. Okay. So for this resistance, we can see many number of resistors here, and we need to simplify the circuit. Right now, how do you simplify this circuit? It's actually very easy. See this part of the circuit. If you see, it is nothing but Wheatstone bridge only. For a balanced Wheatstone bridge, P by Q is equal to what? R by S. And which are those P, Q, R, and S? If you're taking, let's say this is P, this is Q, this is R, and this is S. Let's see if it is balanced or not. See, P by Q, if you're taking what you're going to get 3 by 1.5, and R by S, if you're going to take, what is that? You're going to get 5 divided by 2.5. Both are actually equal to what? 2 only, right? So this is actually a balanced Wheatstone bridge only. So it is very easy for us now. You need not consider this 6 ohm resistance because current will not pass through that. Potential difference between these 2 points A and D will be 0. So no current actually passes through that. So our circuit becomes even simpler now. See, I'm quickly drawing these resistors here, right? So we have the 5 and this is the 2.5 ohm. This is 3, this is 1.5, and here we have this 1.5. Here we have this 1 by 3. You have the battery, which is 5 volt. And here we have this 5.5 ohm resistor also, right? So it's very clear now. This is balanced Wheatstone bridge. So how do you simplify this now? This P and R, if you are seeing, they are actually in series. These two are in series. Now, if you simplify them, 5 plus 3, since they are in series, right? You find in series RS, what is that equal to? R1 plus R2. 5 plus 3 equal to what? 8. And same way 2.5 plus 1.5, which is nothing but 4 ohm. Okay, now what is the simplest thing? This 8 and 4. This is 8 and this is 4. They two are parallel because they are connected between these 2 points. And two resistors, parallel connection, the equivalent resistance, how do you find? 2. For two resistors RP, you can write as what? R1, R2 divided by R1 plus R2, we can write. And if you write, apply this, 8 into 4 divided by 8 plus 4. So that is 32 divided by 12. So if you're simplifying this, what you're going to get? See, like 16, like yeah, 6, and if you are again simplifying, 8 by 3. So the equivalent resistance of this, you're going to get what? 8 by 3. So it's not over yet. So our circuit is now very simple. We have this resistance which is 8 by 3. Here we have a resistance which is 1 by 3. Here you have another resistance 1.5. And here we have this 5.5 that is connected across the battery, 5.5 volt. So now just all are in series basically. All these resistors are in series. So you can write RS is equal to what? Again, R1 plus R2 plus R3 plus R4. What you're going to get? 8 by 3 plus 1 by 3 plus 1.5 plus 5.5. You're going to get what? 8 plus 1, 9 by 3 plus 1.5 plus 5.56, 7 you're going to get, right? So you'll be getting what? 3 plus 7, which is 10 ohm. So the equivalent resistance of the circuit is 10 ohm. So current, how do you find? I is equal to what? V by R. R equivalent. What is V here? V is nothing but what? 5 volt. So 5 divided by 10, which is equal to what? 1 by 2 ampere, which is, you wanted the answer to be 1.1 by 2 or 0.5. You want it as 0.5 ampere, and that is the answer for this question. Okay, right, the next question. Okay, here is the question on vertical circular motion. Okay, we have to do quite a bit of derivation maybe in this question. All right, guys, here is our next question. We have a bob of heavy mass m that is suspended by a light string of length L. The bob is given a horizontal velocity v naught as shown in the figure at the bottommost position, right? If the string gets a slack at some point P making an angle theta from the horizontal, the ratio of speed v of the bob at the point P to its initial speed v naught, what it is the question. What is this thing? At the bottommost point, this is having a velocity v naught. At point P, it has velocity v. The question is to find what is this ratio, v by v naught, correct? Right. So here, what we apply the conservation of mechanical energy. We know potential energy, we use the relation mgh, right? And the kinetic energy relation half mv square. And the total energy, obviously, you can write u plus k, right? At these 2 points, we can equate the total mechanical energy. That's what we are going to do in this problem. Okay. So how we can start with, we write the equations for the conservation, mechanical energy conservation, right? So at the bottommost point, at the topmost point, if we are going to write these energy relation, how is that going to be? Right. At the bottommost point, we take actually the reference level to be what? The bottommost position, right? With respect to that, we take suppose the potential energy at that point, right? Potential energy like that we can actually take. So at the bottommost position, potential energy is zero, right? So with respect to that, at point P, what it is using, right? So what you can write at these two positions when you compare. First, let's write the energy relation at the bottommost position. We know that the potential energy is zero plus kinetic energy. How much is that equal to? Half mv naught square, correct? And that will be equal to these same values at the topmost position, right? At top position, what will be the potential energy? You need to know this height, right? And how much is that equal to? This much is L, right? And how much will this be equal to? See, if I consider a triangle here, right, this is L. So this will come obviously L sine theta, correct? Opposite side it is coming, correct? So you can write the height, this length will become what? L sine theta. So the total length will become L plus L sine theta, correct? So potential energy becomes what? Mg. If I take L plus L sine theta, L if I'm taking common outside, 1 plus sine theta, we can actually write. And the kinetic energy will be nothing but what? Half m v square. This is what the relation is, right? So what we can do here, let's say the mass terms from both the sides, I'm cancelling off. And if I multiply with the 2 on both the sides, you get what? V naught square, that is equal to 2gl into 1 plus sine theta, right? Plus v square, right? This is what the term that you'll be getting. See, one more relation that I'm going to write based on tension, right? How we can write this based on tension? See, if I take, suppose at the topmost position, the tension in the string is T, correct? We know that at that point it is slacking, so the tension is zero there. Here you need to note, I'm actually considering a component of the weight of this, that is mg along this direction. How much that will be coming, right? This component will be mg cos theta and this will be mg sin theta. We can actually write, correct? So you can write basically T plus mg sin theta from this diagram. We can write that as equal to what? These two together are providing what? The centripetal force. So we can write centripetal force is nothing but what? mv square by r. And this r is nothing but equal to what? The length only. And at this point, at P, if you are taking, it is slacking, so the tension is zero also here. Correct? So you can write mg, if I take r to the left hand side, which is nothing but L, you get mgl sine theta. What is that equal to? Mv square you can write. This m will get cancelled also. you will be getting V square that is equal to what? GL sine theta. Okay. So here is our first equation. Here is our second equation. So what we do, we can actually substitute. You can substitute 2 in the first equation. Right? V square, in place of this V square, you can substitute what? This equation we can substitute. So what am I going to get here? V naught square, that is equal to what? 2GL into 1 plus sine theta plus V square is nothing but what? GL sine theta you'll be getting. Right? So if we expand this, what is that you're going to get? 2GL plus 2GL sine theta plus GL sine theta. What are you going to get? 3GL sine theta we are going to get. Right? So if I take suppose GL common outside, what am I going to get? 2 plus 3 sine theta. Correct? GL, if I take common outside, 2 plus 3 sine theta. That is what V naught square is. Let's say this is equation number 3. So what are we having here? We have the equation for V naught square, which is V naught square. We have V naught square is this, correct? V naught square is this. And we have V square, which is nothing but this equation, correct? So what we can do now, we can easily find the V by V naught. How you find that? V square divided by V naught square. What is that equal to? GL sine theta divided by GL into 2 plus 3 sine theta. Very simple here, right? So GL both will get cancelled. And if you take root on both the side, we get V by V naught, that is equal to root over sine theta divided by 2 plus 3 sine theta, right? Or coming to the notation that you can see in the problems, right? You need to the power half. Root is nothing but to the power half. So we can write V by V naught, that is equal to what? Sine theta divided by 2 plus 3 sine theta whole to the power half. And that is our answer here. And which one it is? Option sine theta divided by 2 plus 3 sine theta. So the answer is nothing but what? Fourth option will be the correct answer. Right. See here, I'll tell you one more thing. See, if suppose if this is lengthy for you, you can go with the equation for the velocity at different position. We have the equation, right? So that equation also, if you want, we can actually use, right? So if I'm taking, see, we have the general case like this. See, if this in vertical circular motion, if at an angle theta like this, if you are taking, right, the mg weight and we have this mg cos theta, right? At this position, if we have, if you can write the relation for velocity. What is the relation for velocity? We can write it as what? V, let's say at angle theta, right? What is that equal to? We have V theta square. What is that equal to? V naught square minus 2gr into 1 minus cos theta. This relation, if you want, you can use where this r is the radius of this, right? But make sure that in the given problem, theta is different. So you will be having to take it like a cos 90 minus theta like that you'll have to be taking. So obviously this will change into the sine terms it will be coming, right? And obviously at this case, the tension, T theta, if I'm writing, that will be equal to what? MV theta square by R plus mg cos theta relation also will be coming, right? So directly using this equation also, we can actually use, apply this problem where this equation is actually derived with what? Energy conservation, right? This, whatever we have done, initial steps, directly you can actually jump over to this. All right, let's go for the next question now. Right, so here is the next question, the eighth one. The output Y of the logic implementation is similar to the output of an or a gate, which one it is, right? So the output, which it correspond, what is the equivalent circuit is what we need to see, correct? Is it an AND gate or gate, NAND gate, NOR gate? I know you will be knowing the fundamentals of these things. Okay, so how to analyze these questions? See, what approach am I going to take in this? We'll use the truth table and easily we can actually find this one, correct? This is nothing but OR and a NOT that is coming. So this is a NOR gate. This is a NAND gate, right? And in front of it, there is a NOT. And this is an AND gate, right? So this, when you apply for different, for example, the truth table, if I'm going to draw, how will be the truth table? We have A, we have B, and this is Y. So for the different inputs, we are seeing 0, 0, 0, 1, 1, 0, and 1, 1. What will be the output is what we are going to see. So we can see here, first let's apply A and B both 0, correct? So A and B both are 0. So you see the NOR gate here, see, or how it is, it will give output 1 if both the input or one of the input if it is high, correct? So here in this case, the first, this NOR gate, if you are seeing for OR, and then a NOT also coming after that, right? So 0, 0, after passing through the OR gate, what will be the, through the output, it will be 0. And after a NOT is coming, so the output will be what? 1. Similarly, NAND, if you are taking 0, 0, output what will be for the and it will be 0 and output what it is going to be 1. So and how is the result for and gate? It will give output as high only if both the inputs are what? High. So here already 1 and 1 only, so the output is going to be what? 1 only it will be, correct? So let's do the same for now, 0 1, correct? So now A is 0, right, and B is what? 1. So in this case, how it will be OR gate passing through one of it is high, correct? So for OR, you'll be getting 1 and passing through NOT, it will go what? 0. But NAND, what it will be? B or C, both should be high to get output uh, high, correct? For AND gate. So after passing through the AND gate, this will be 0. After passing through the NOT, it will be like 1 only, right? So again, if this same thing is passed through AND, what will be happening here? 0 and 1, output will be obviously what? 0 only here. So you'll be getting 0. Correct? So the same if we do for now, yeah, let's do it for uh, 1 and 0. How it will be? A is 1, B is 0. Correct? After passing through or A and B input 1 and 0, what will be 1? Passing through not again 0. Correct? 0 you'll be getting. For the NAND gate, how it will be? 0, 1. So after passing through and it will be 0. Passing through not it will be 1. Right? And after passing through and output will be obviously what? 0. Correct? The same thing if we do it for now, yeah, if we do the same for last one, 1 and 1, all are 1. So here what will be after passing through or 1, after passing through not, it will be 0, right? For the NAND, how it will be after passing through and it will be 1, after passing through not, it will be 0. So the output will be after passing through and finally you'll be getting what? 0, right? So what is this actually? We know the truth table. See here, what is the thing? Only when it is 0 and 0, you are getting output 1. This is actually, it's like, see, if you are seeing an OR gate, correct? A, B, the truth table of this, how it is 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. Correct? This is like coming what the reverse of this, right? So the output of OR, if you pass through a NOT, right, you will be getting what this result you're going to get. So this is nothing but an OR plus NOT. Your answer will be what? NOR gate is what you'll be getting. So the answer will be what? The fourth option. NOR gate is what you'll. So here we have the ninth question. This is on electromagnetic wave. The equation for electric field is given. You are asked to find what will be the equation for magnetic field. Correct? See, this is not even without solving this, to finding the values and all relative values, you can tell the answer very quickly. What is the thing? With the propagation direction of electromagnetic wave, x direction, the propagation of, I mean, in what direction electric field is and in what direction magnetic field is, we know the relationship between them, right? They will be in the three mutually perpendicular directions, right? So in this case, the electric field fluctuations are the z plane that is given, correct? And the propagation is along the x direction, correct? Because it is given kx plus this omega t form, right? So propagation is in the z direction, right? Z direction it is. So obviously, we can actually find quickly now in what direction this will be. This will be obviously in the y direction only. The magnetic field fluctuations will be in the y direction. So, but there are two options that are coming. You can see here this option as well as this option, both dy only. What is the difference here? Is it you can see here now? Quickly jump into the amplitude of magnetic field, and amplitude of magnetic field easily you can connect it by using this relation, magnetic field and electric field fluctuations, how they are related. We can actually find here. How you find that E naught by B naught, what is that equal to C, correct? You need to know the actual velocity you find here, that will be better, correct? Because sometimes if it is in any other medium, the velocity will, you can take it as V, right? It may not be C, which is 3 into 10 to the power 8. So V, how do you find? It is given, K value is given, that is 5, right? Omega is given as what? 1.5 into 10 to the power 9. So V, how do you find? V, you can find it as omega by K. How much is that? 1.5 into 10 to the power 9 divided by 5. How much is that? Equal to 0.3 into 10 to the power 9, or that is nothing but 3 into 10 to the power 8 meter per second. So it's nothing but in vacuum only. So here we can write this relation here now. B naught, what will that be? Equal to E naught by C. And E naught value is given 60 divided by C value is nothing but 3 into 10 to the power 8. So you'll be getting 20 into 10 to the power minus 8, right? Tesla. Tesla only, right? So that will be equal to what? You want to get it like 10 to the power minus 7. So 2 into 10 to the power minus 7 Tesla is the peak value of magnetic field. So obviously you can see here in this section, option 1 is following this thing. Why not option 2? Because it is, you can see this is along x direction, right? The magnetic. But here in our problem, this is along y direction only. So the correct option is nothing but 1. What is our next problem? Question number 10. A ball of mass 0.5 kg is dropped from a height 40 meter. The ball hits the ground and rises to a height 10 meter. The impulse imparted to the ball during its collision with the ground, how much is it? Take g is equal to 9.8 meter per second square, right? Here we are having a ball, correct? And this ball is of mass 0.5 kg, and this ball is dropped from a height of how much? 40 meter. So you are dropping its initial velocity. Free fall we are considering, right? So it is falling through a distance of how much? 40 meter. The ball hits the ground and it rises to what height? Just 10 meter only. So it is an inelastic collision. It will lose some energy there, right? So it rises to 10 meter. What is the impulse imparted? Correct? How do you find impulse? See, impulse, we can write it as equal to what? Very easily, the change in momentum, right? That is final momentum minus the initial momentum. So we consider the ball just before hitting the wall, I mean, like the floor, and just after hitting the floor. So with what velocity it hit the floor and with what velocity it rises up. These two velocities, if we can find, we find this is the final state of this, right? Because we are considering what the impulse that is imparted by the wall. So the impulse that is imparted by the floor on the ball actually causes change in momentum of what? The ball. So we find the final momentum, correct? Which is nothing but mv, and initial momentum, you can find it as what? Mu. You need to note that they are in the opposite directions. So with the sign, you need to apply this, right? So here, how much is these two velocities? U and V, let's find it. Okay. We know that for free fall, the velocity at the bottom most point, you can write it as what? V is equal to, we use the relation V is equal to what? Root 2 GH. So you can write it as equal to what? Root 2 GH when you are applying. What is that? You're going to get root over 2 into 9.8 into what is H here? The 40. Correct. So what is that you're going to get? Right. Root 80 into 9.8. How much is root 80 into 9.8? It's like a root 8 into 98. Correct. So 98 into 8. 6. 78. So that is equal to root 784. Now, what is root 784? This is nothing but what you can write it as what? 28. So initial velocity is 28 meter per second on. So U is equal to, you're getting 28 meter per second. So same way, with to what height it rises also, you can use the same relation. V is equal to, basically, you apply what? V square minus U square equal to 2A as a relation if you apply 0 minus the initial velocity, we are taking U square only, minus 2gh. Solving this, we can get that velocity, with what velocity the body is projected. So that also we are using the same equation only. So what you're going to get? 2 into 9.8 into, to what height it is rising? 10 only. So you'll be getting here what? Root 2 into 98. What is 98 into 2? 80 plus 196, root 196, which is nothing but what? 14 meter per second. So here we get the initial velocity, both the velocities we are getting 28 meter per second, 14 meter per second. So impulse, how do you find the final momentum minus the initial momentum? How much is that equal to? What is the final momentum? You can write it as mv, correct, minus, see, initial momentum, we have to take it in the opposite direction. So minus mu, correct. So what is that you're getting? M into v plus u is what you have to do. So what is m here? M is nothing but what is the mass of the ball? It is given 0.5. 0.5 into v is nothing but what? 14 plus 28. How much is that equal to? 0.5, obviously it is 1 by 2 into 28 plus 4, 32 plus 10, 42. You're going to get what? 21, correct? Newton second. That will be the SI unit for impulse also, right? So 21 Newton per second will be the answer. So the clear answer is nothing but option number 1. Yeah. Question number 11. We have AB is a part of electric circuit as shown on the figure. The potential difference VA minus VB at the instant when current I is equal to 2 ampere and is increasing at a rate of 1 ampere per second. How much is it? The question. Correct. So what we use here, we can apply the Kirchhoff's voltage law very clearly, right? And how do I, if I write this in this inductor, right? The EMF that is developed across this inductor because the current is changing, right? If I take the current, the rate of change of current, if you are going to take, suppose di by dt, if you are going to take, correct, the induced EMF across that, you can write it as what? Minus L di by dt. The current is increasing, so this will be opposing. That you need to keep in mind, correct? This will be opposing. So you can consider this as an opposing EMF, you can consider, right? How much is that equal to? Minus L di by dt, correct? That you need to know. Now, if suppose if I move from A to B, and let's say the potential at A is VA, at B, let it be VB, correct? So if I'm going to apply from point A to B, if I'm moving, how do I write the potential variation? How we can write? At the point A, potential is VA, correct? Now, so you are moving across the inductor now, correct? When you go across the inductor, you have an opposing potential that is there, minus L di by dt, correct? Now from here, if you continue, you're going across a cell, you're moving from the positive to the negative terminal. So potential is decreasing. So you can write it as what? Minus 5 volt. It is 5 volt only. Now you're going in the direction of current, correct? Current direction is same of how actually you're going. So potential across the resistor, you cross the resistor, potential drop. How much is that? Minus 2I. I is the current. That is equal to what? The potential at the point B. And you need to find actually VA minus VB only. So let's write this one, VA minus VB. Let's take these all terms, let's take it to the right hand side. So L di by dt plus 5 plus 2I is what you'll be getting. And what is L here? 1 Henry. Di by dt is given 1 ampere per second. So into 1 plus 5 plus 2 into what is the current? That is 2 ampere. So into 2. So 1 plus 5 plus 4. How much is that equal to? 10 volt. And that is the answer for this question number 4. Right. Let's go for next question. Question number 12. This is question number 11 and question number 12. What is this? A 2 ampere current is flowing through two different small circular copper coils having radii ratio 1 is to 2. Right? We have two copper coils. Their radius ratio is given. Let's take radius is R1 and R2. It is R1 is to R2, that is equal to 1 is to 2. The ratio of their respective magnetic moments. So if we have a current carrying coil of radius R, suppose I is the current through this, you have the relation for magnetic moment. What is the relation for magnetic moment? If there are n turns for the coil, general relation you can write it as what? NIA. Okay, I often keep this in mind, like National Investigating Agency, right? You can keep it in mind like that, NIA. So since in the given problem, both the loops are having single loop only, correct? So a number of turns is one only. And 2 ampere current only flowing through both, correct? So here the magnetic moment, dipole magnetic moment is proportional to what? Area only. Or you can write in terms of radius if you are taking. Area is nothing but pi r square, circular area only, no? So proportional to what you can write? R square. So very easily we can write what is that? M1 by M2. What is that equal to? Their respective magnetic moments is what we need to find. So M1 by M2 is nothing but what? R1 by R2 the whole square. So R1 by R2 is nothing but 1 by 2. So 1 by 2 whole square. So you get M1 by M2. What is that equal to? 1 by 4. And the answer is 1 is to 4. So the option 1 itself is the answer that you'll be getting here. So what we have got next, question number 13. What is that? In a certain camera, a combination of four similar thin convex lenses, right? We have four similar convex lenses. So they are placed, arranged axially in contact. So they are placed like this. They are arranged in contact. Four. Then the power of the combination of the and the total magnification in comparison to the power P and M of each. Each are having power P and magnification M. Correct? So what we use here, we use the idea of combination of thin lenses. The power relation being nothing but what P1 plus P2 plus P3 plus P4. Very simple question, correct? What is that equal to? P plus P plus P plus P. And what is that equal to? 4P. Very good, right? So very clearly it is nothing. Either it can be option 1 or 3. Now which out of that it will be? We'll confirm with the magnification. How you find the combination of thin lenses? The magnification you can read as what? It is actually the product of the magnification, correct? One lens is producing a certain magnification that is again magnified by the next means, right? Net magnification will be what? The product. So M1 into M2 into M3 into M4, which is nothing but M into M into M into M, which is nothing but what? M to the power 4. So your answer will be what? 4P and M to the power 4. So your option will be option number 3. That is the answer. Okay, the 14th question, what is it? We have an oxygen cylinder of volume 30 liters. Okay. We have an oxygen cylinder of 30 liters volume. V is equal to 30 liters. It has 18.20 moles of oxygen. Okay. Number of moles are given. After some oxygen is withdrawn from the cylinder, its gauge pressure dropped to 11 atmospheric pressure at temperature 27 degrees Celsius. This is at 27 degrees Celsius that is happening. The mass of the oxygen withdrawn from the cylinder, how much it is nearly? Correct. What we can use here, we can use the ideal gas equation. PV is equal to what? nRT, right? So here the pressure after removing the oxygen gas, some of the oxygen gas, uh, volume will remain the same. It is 30 liters only. You are not changing the cylinder, correct? Temperature is 27. Pressure drops to what? 11. That final pressure is given. How much is that equal to? The final pressure is given. That is equal to the gauge pressure is given. That is very important, correct? 11 atmosphere is the gauge pressure. So the absolute pressure, what will be? Plus atmospheric pressure you have to do. So 11 plus 1, that is 12 atmospheres. That you need to keep in mind. Correct. And the 12 ATM is nothing but what? 1.01. Correct. It is given. 1.01 into 10 to the power 5 Newton per meter. Even this liters, what is the SI unit for this? 30 into 10 to the power minus 3 meter cube. And 27 degrees Celsius, obviously it will be what? 300 Kelvin also, correct? So let's do this. What we have to do, initial number of moles is given. How much is the initial number of moles? 18.20 moles, correct? It is given like that. So what we do, final number of moles we'll find. By what equation? N is equal to what? PV by RT. PV is equal to nRT, so N is equal to what? PV by RT. We substitute the values, we find the final number of moles. And when you get the final number of moles, what we can do, just we can just put the final mass we can easily find, and that difference will be obviously, or you find the difference in the number of moles that you have differences between those moles will find, right? And you multiply by the molecular, the molar mass, you will be getting the answer, correct? So here we can, let's find this value, put the values here. What is that? P is what? Nothing but 12 into 1.01 into 10 to the power 5 into the volume is what? 300 liters. So, sorry, 30 liters. 30 into 10 to the power minus 3 divided by R value is given. Easily it is given like 100 by 12. Note down this value. If it is coming properly, you can use it for further relations also. 100 by 12, right? Into, we have temperature. How much is that? 300. How do you simplify this? Yeah, the easiest way, simplest things you cancel off first. You have got 10. Correct. 12 will go to numerator. So I'm always telling this, better bring all those numerical values together, powers differently will manage together. So here 12 into 12 is there into 1.01. Remaining things are all sorted, right? In the numerator, we have 10 to the power 5 minus 3, which is nothing but 10 to the power 2, correct? And in the denominator, 1, 2, 3 zeros are the 10 to the power 3. So you'll be getting 10 to the power minus 1 into the power. So 10 to the power minus 1. Very simple relation. So you'll be getting what? 144 into 1.01 into 10 to the power minus 1. Okay, we have to solve this. How do you simplify this? Let's see 144 into 1.01, how much it is, right? 101. You have got 144. Correct. And 10 you have to put here. So again 144 here also. So 541. So 145, 2 points are there, right? So 145.44. Correct. 145.44. That will be the number of, oh, that many number of moles. Okay, into 10 to the power minus 1 is there, correct? So you'll be getting 14.4 approximately. I'm taking the number of moles. The final number of moles is 14.5 moles. So what is the difference? This is the initial number of moles. This is the final number of moles. That difference, what it will be, N1 minus N2, you're going to get. How much is that? 18.20 minus 14.5. Correct? So how much is that? 0. 12 minus 5, 7. You've got 7 minus 4, 3. This is what? 3.70. So we are getting N2 minus N1. What is that? The difference in the number of moles is 3.7. Correct. So what we do here, the number of moles and the given mass and molar mass relation. Number of moles is what? Given mass by molar mass. Correct. So the mass corresponding to that number of moles, the gas that you have taken. If n moles are there, the total mass of the gas, you can write it as what? N into the molar mass. Uh, Molar mass we can actually write. So this mass, you can write it as what? N2 minus N1, which is nothing but 3.7. Correct. 3.7 into molecular weight. It is oxygen, correct? O2 gas it is. So it's more like 1 mole of this will have mass that is equal to how much? 32 gram. You can actually take in this case, correct? So what is your answer that is going to be? You will be getting the answer that will be 3.7 into 32. Let's do 37 into 32. How much is that? 4, 2, 3, 6, 7, correct? And you'll be getting 4811 118 we are getting 118, yeah, 118.4 gram is what you'll be getting. 11.11.8, sorry, 118.4 gram. In kilogram, if you are writing this, obviously it will be what? 0.118 kilogram, right? Or approximately near to this value, we can take this as the final answer for this. And you'll be getting the answer what? Option number 3, which is 0.116 kilogram. That will be the answer. So effectively, we have used the ideal gas equation, which is nothing but PV is equal to nRT, and this N is equal to M by M relation we have used here. What is the next question? 15th one. In some appropriate units, time t and position x relation of a moving particle is given by t is equal to x square plus x, the acceleration of the particle. How do you find acceleration? If position is given as a function of time, x of t. You differentiate this once, dx by dt. This is nothing but velocity. And you differentiate it again, d square x by dt square. This is what? Acceleration. So from our given relation, how to reach to acceleration? It is given t is equal to what? X square plus x. So how we can do this? We need to find basically acceleration is nothing but what? D square x by dt square, right? So dt square it is, not dt. So let's find this one. What we have to do, this equation that is given, you differentiate it with respect to time itself. For left hand side, since it is time only, you get 1 that is equal to what? 2x plus 1, correct? Into dx by dt also will be coming, correct? 2x plus 1 because, right? 2x plus 1 with respect to time you differentiate. So you get actually dx by dt, which you can write it as equal to what? Velocity. That is equal to what? 2x plus 1. If you take to the left hand side, you get 1 by 2x plus 1. Correct. So we have got velocity, or dx by dt is this. So now obviously acceleration, you can find it as what? D square x divided by dt square. Now that is equal to what? D by dt of dx by dt, already you have 1 by, or velocity, 2x plus 1 relation we are having. Okay, how do we do this? D by dt, this differentiation, how you can do 2x plus 1 whole to the power minus 1. How do you simplify this? What is that equal to? Minus 1 into 2x plus 1 whole to the power what? Minus 1 will come, correct? Into d by dt of this part also, which is nothing but 2x plus 1. So what is that you're going to get here? Uh, yeah, what we have got? Minus 1 into 2x plus 1 whole to the power minus 2 will come. When you differentiate this, what is that you're going to get? 2 into dx by dt, correct? 2 into dx by dt. Second part will become, it's a constant. Hmm, right? So how do you simplify this? Minus 1 into 2 is 2 only, divided by 2x plus 1, 2x plus 1, the whole square. 2x plus 1 whole to the power minus 2 we bring to denominator. Into what is there? Dx by dt is also there. Dx by dt is nothing but velocity, and this relation here we are having. So that also we put in this relation. You get acceleration that is equal to what? Right? If I take it to this step, this point here, you get minus 2 divided by 2x plus 1 whole to the power 2, correct? Into dx by dt is nothing but 1 by 2x plus 1. So the denominator will be minus 2 divided by 2x plus 1 whole cube. And this will be the acceleration you'll be getting. And that's the solution. So what is that? Minus 2 divided by 2x plus 1 whole cube. You will be getting option 2. That is your answer. Going for the next question, the 16th one. Let's read the question. To an AC power supply of 220 volt at 50 hertz, a resistor of 20 ohm, a capacitor of reactance 25 ohm, and an inductor of reactance to 45 ohm are connected in series. The corresponding current in the circuit and phase angle between the current and voltage, how much is it? Correct. What all things are given in the question? The RMS voltage is given, which is nothing but 220 volt. Frequency is given 50 hertz. Let's see. We have the resistor 20 ohm, a capacitor of reactance. The capacitive reactance is given 25 ohm. The inductance of reactance, the inductive reactance is given 45 ohm. They are connected in series. So it is a series LCR circuit. R, we have L and C. They are connected. Hmm. So corresponding current in the circuit. Current, how do you find the current? IRM, the RMS value of the current. We can find it as what? VRMS divided by Z. What is Z? The impedance of the circuit. How to get the impedance? Impedance is nothing but root over R square plus XL minus XC the whole square. Whichever is bigger or square is coming, so that negative will get cancelled. So you can write root over, what is R here? 20. So 20 square plus XL minus XC, we have 45 minus 25, the whole square. How much is that? Root over 20 square, which is nothing but 400 plus, yeah. So here also 20 will come. So that is also 400 only. So root 800 will be coming. Correct? Huh? Root 800. So that is nothing but root 8 into root 100. So root 100 is nothing but 10, right? 10 into 8 is nothing but 2 into 4. You can write this as what? A root uh, 2 into 4 into 100. Correct? So this 400 will come out 10 into like a 2 is there into root 2 is there. So 20 root 2. This is what the impedance that will be getting. This much ohm. This is what the impedance that will be getting here. Correct? Huh? So current is what you need to find. How to find current now? Current is nothing but what? VRMS, which is nothing but 220 volt divided by 20 root 2. Now, how much is that? 0, 0 will get cancelled. 11 divided by root 2 is 1.414. Let's check our options here. You have either 7.8 and 15.6. See, you're dividing 11 with 1.414. I'm not going to do this. You can think of this very clearly. It will be a quantity less than 11 for sure. 11 you're dividing with a quantity that is more than 1. So it will be obviously what? 7.8 only. Only those two options are there. No. So let's take 7.8 only as the impedance value. I mean the current value. So you can take it as what? 7.8 ampere. I'm not doing the calculation here. Correct? You can check it. It will be coming out the same value only. Now, at the same time, you need to find also the phase angle between current and voltage. How to find the phase angle? We have the relation tan phi. What is that equal to? We have the impedance triangle, right? What is the impedance triangle here? If this is the phase difference, we have XL minus XC. This is R, and this is the impedance. So obviously, tan phi is nothing but what XL minus XC divided by R. What is XL here? We have 45. Yeah, 45 minus we have 25 divided by R is nothing but 20. So how much is that? You get 20 by 20, 20 by 20, which is nothing but 1. So tan phi is equal to 1. Phi will be equal to what? 45 degree, obviously. So your answer 7.8, and we have 45 degrees the phase angle. So the option will be option number 2, 7.8 ampere and 45 degree. That will be the answer for this. Right, students, the next question, 17th one. The sun rotates around its center, right? Once in 27 days. What will be the period of revolution if the sun were to expand to twice its present radius without any external influence, right? Assume the sun to be a sphere of uniform density. So the sun is like we have sun. Yeah, yes. So here we have sun of certain radius. Let's say initially it is of radius r1. So now it expand to twice its present radius, correct? Or let's say initially R means now it is like what 2R. Without any external influence it is. So mass is not changing. You may take it like the mass is same, right? So sun rotate about its center with respect to once in 27 days. What will be the period of revolution if the sun were to expand to twice its present radius without any external influence? So what we do here very simply, we apply the conservation of angular momentum, correct? Law of conservation of angular momentum we are going to apply. We know the angular momentum. If I is the moment of inertia and omega is the angular velocity of revolution if you are taking, you can write L is equal to what? I omega. Or you can write I, this law of conservation of angular momentum, what it is telling, I omega, this will be a constant value, right? So you can write I1 omega 1, that is equal to what? I2 omega 2 easily you can write. Omega and time period are still related. Omega is nothing but what? 2 pi by t. So you can write in this relation that both the sides 2 pi will get cancelled. So you can write I1 by T1. What is that equal to I2 by T2? What about moment of inertia? You can think of like it is a solid sphere. So from both the sides, you will be this two, you can consider it will be getting cancelled. So you can write mr square by T1, that is equal to what? Mr1 square you have to take. So mr2 square divided by T2. It's given that T1 is nothing but what? 27 days. So T2 is what we need to find here. Correct. How to get T2 now? T2 is nothing but the mass get cancelled. T2 is nothing but what? R2 by R1 the whole square into what? T1. Very clear. So this is nothing but what? 2 by R1 is nothing but what? It's given that R2 is twice R1. So 2 square T1. So 4 times what is T1? It is 27. So you'll be getting what? 27 into 4. 4 sevens are 28, 2 was 8, 10, 108. You'll be getting 108 days. That will be the answer. So option 4 will be the answer for this. Right. So what have we got here? The next question, question number 18. A model for quantized motion of an electron in a uniform magnetic field B states that the flux passing through the orbit of the electron is n into h by e, where n is an integer, h is the Planck's constant, and e is the magnitude of electron's charge. According to the model, the magnetic moment of the electron in its lowest energy state, what will be? Correct. Right. So here, what is that thing? We have a uniform magnetic field and the electron is moving in that, right? Motion of an electron in uniform magnetic field. If suppose this electron is moving perpendicular to this, right? Or in a general case, the perpendicular component of field to the motion of electron, if you take it as B, we have the radius relation, right? That is a clear non-relation for this. What is that? R is equal to mv by qb, correct? If we have a perpendicular magnetic field and an electron is moving in this will go in circular path, correct? So R is equal to M, the radius of this is given by R is equal to mv by qb here, correct? So that is one point we can use here. What else is there? The flux passing through the orbit of electron is this, correct? So flux we know it is nothing but what B into A, correct? And this flux they have given is equal to what? NH by E. That is also there. Or area is nothing but what? Pi r square because it is circular. B into pi r square we can write it as what? NH by E. Hmm. Let's put r square. What is r square equal to? NH divided by BE, correct? Pi is also there. Pi BE. NH divided by pi BE. That is one relation we can use here. And we have R is equal to MB by QB, right? Okay. So here, what is it we need to find? We need to find actually the magnetic moment. How to find magnetic moment? M is nothing but what? NIA, correct? For this is an electron that is revolving, correct? The magnetic moment due to that, the current due to the movement of electron, I mean the revolution of electron, you can write as what Q by T. In this case, over one time, the time taken by the electron to revolve once, if you take it as T, the charge flowing in that time is E. Or you can write it T we can write it as equal to what? 2 pi r by V, correct? If the circumference is 2 pi r, V is the velocity with which it is revolving. You can write EV by 2 pi r. We can actually write here, right? And the area is obviously if the radius is r pi r square only. Number of turns you can take it as what? 1. So here this will become EV divided by 2 pi r, right? Into the area is nothing but what? Pi r square only. Okay. So here this pi let it get cancelled. So E by 2 is there and V you are having and R square. Already we have the relation for R square. And this V by R is there. Sorry. Here we have this V by R also. We find V by R from this relation. What will be V by R? V by R is QB by M. Correct. So that if we put in this, we get the relation E by 2 into V by R is what? QB by M. Correct. Into R square is nothing but what? NH divided by pi BE. Correct. So what are the things that you can cancel off? B you can cancel. Anything else is there? No, nothing else is there that we can cancel. So you get NHE divided by 2. Oh, E also you can cancel, right? So E also will get cancelled. NH by 2 pi M. So your answer will be what? The magnetic dipole moment is NH divided by 2 pi small m. M is the mass of electron you'll be getting. NH divided by 2 pi m. But here you can E. What about E? How did E get cancelled? E got cancelled here. NH divided by pi BE. Mm, NHE, NH by E. Correct. That is correct only. NH divided by pi BE. Mm. V by R is QB by M. Oh, here one more. This is also there now. This Q is nothing but what? Charge only. This you will write it as what? EB by M. So that one more E also will be coming, correct? So your answer will be what? E is also there. NHE divided by 2 pi M, correct? So here the lowest most orbit is the question. Lowest state, lowest energy state. Lowest energy state means what? N equal to 1 only. So you'll be getting magnetic dipole moment in that. What is that equal to? He divided by 2 pi m. That will be the answer. He divided by 2 pi m. Option number 2 we can use in this particular case. That will be the answer for this. Question number 19. We have three identical heat conducting rods that are connected in series as shown in the figure. The rods on the sides have thermal conductivity 2K, while that in the middle has thermal conductivity K. So 2K and K. The left end of the combination is maintained at a temperature 3T and the right end at temperature T. The rods are thermally insulated from outside. In steady state, the temperature at the left junction is T1 and at the right junction is T2. Correct. What is the ratio of T1 by T2 is what we need to find. So here we have T1 by T2 we need to find. Okay, so here at steady state conduction only, so it is very easy problem. In steady state, we know that the heat current that is flowing through everywhere, that is the rate of heat flow will be the same. we have the rate for flow relation. What is that equal to Q by T, or that we call it as the heat current. What is that equal to Ka into theta 1 minus theta 2 by L, correct? So heat current is proportional to the area of cross section, temperature difference, and inversely proportional to the length. K is the coefficient of thermal conductivity here, right? So if I write for these three different rods, this equation, if I'm going to write, you can equate between this because they are in series. The heat current will be the same, or the rate of heat flow through each will be same. So the first, if I'm writing the leftmost conductor, if you are writing, its thermal conductivity is 2K, correct? Area of each is same only, right? And the temperature is what? 3T minus T1 I'm going to write. Divided by length is three identical rods it is. So length also same. Area of cross section length is same. This for the center rod, you can write it as what? Coefficient of thermal conductivity is K only. A into T1 minus T2, correct? Divided by temperature difference is T1 minus T2. Okay, from the hot end to cold end, basically the heat will flow, right? So temperature difference like this you have to take equal to L, and that will be equal to what? 2K, coefficient of thermal conductivity of the rightmost one, into A into temperature difference will be what? T2 minus T divided by what? L. So what all things you can cancel here? Ka is common everywhere. We'll cancel. Length is common. We'll cancel. So if I expand this equation now, 6T minus 2T1, that is equal to what? T1 minus T2, and that is equal to 2T2 minus 2T. Correct? This is our relation that we have got. Now, what is that? We need to find the ratio T1 by T2 if you want to find. Yeah, you have to use these. You can actually frame two equations in this, right? How to frame two equations? Suppose if I take the left equation here, I can write what? 60. Let's equate with a T. That's the possible easiest thing. So what you can do, 60, you can write equal to what? 60 is equal to what? 2T1 if it goes to the right hand side, right? 2T1 plus T1, you will get 3T1 minus T2, correct? That is one equation we can write. And if I'm going to write the middle one, the other equation, if I'm going to write, what is that you'll be getting here? Again, for T I'm taking here, we have the relation what? T1 minus T2, that is equal to 2T2 minus 2T. 2T. So this 2T equation, if I'm going to take 2T, that is equal to what? 2T2 plus T2 minus T1, it will come, correct? Because this side took this side, this equation, I mean left hand side, I took to the right hand side. So you get 3T2 minus T1, right? That is what 2T. So if I multiply this equation by 3 both the sides, you will be getting our relation here. What is that? You'll be getting 60, that will be equal to what? 3T2 is there, so plus 3T2. With the 3 you're multiplying. Sorry, 3 threes are 9 will come, correct? You're multiplying both the sides with the what? 3. So 6T, that is equal to 3 threes are 9T2, correct? And here it will come minus 3T1. Okay, this is our equation. So now you can equate between these two. What is our thing here? You have the first and second equation. What we can do, we can equate. We have 3T1 minus T2, that is equal to what? Minus 3T1 plus 9T2. So 3T1, if it come left hand side, you get 6T1, that is equal to what? 10T2 is what you're going to get. So what is our answer required? T1 by T2 is what you need. So 10 by 6. You simplify, you get 2 will go in both, right? 5 by 3. 5 by 3 you get, and that's the answer that you'll be getting. The ratio you're going to get will be like what? The ratio the ra- the ratio that you're going to get will be like 5 by 3 is what you'll be getting. So option 3 will be the answer that you'll be getting. Here's our 21st question. Two cities X and Y are connected by a regular bus service with a bus leaving in either direction every 10 minutes. A girl is driving scooty with a speed of 60 km per hour in the direction X to Y, notices that a bus goes past her every 30 minutes in the direction of her motion and every 10 minutes in the opposite direction. Choose the correct option for the time period of the bus service and the speed. assumed constant, right? Speed of the bus service is constant. So the speed and the time period you need to find for the buses. Okay. So here, if we are seeing, what is that? We have two cities, right? We have X and Y. These two are the cities. They are connected by regular bus service, it is being told, right? And we have a girl who is going in a scooty, correct? Let's say the velocity of scooty, we can take it as what? V, okay? It is going from, the girl is going from X to Y, correct? Now here, the most important, from X to Y bus is going, from Y to X also continuously the bus is going. Okay. Keep in mind here, for example, two buses going from, let's say the velocity of bus is VB, right? They have the constant speed. Bus is going with that constant speed. From X to Y, if it is going, since they are going with a constant speed, always there will be a same separation between them. Let's say it is V, let's say it is D. The same thing here also, the bus that is going from Y to X also, that speed is also same only VB, like that it is being told, right? See, assumed constant, speed assumed constant of the buses. So, since actually they are going with the same speed and also time period of the bus service, that is also constant. The distance between these two buses or any two buses, okay, consecutive buses will be the same, correct? So here, how to analyze this problem? See, this we are going to apply the concept of relative velocity only. Easily we can actually solve this, right? With relative velocity, right? How you find relative velocity? Let's analyze this. So let's see here. If you are considering the girl is going with the speed v, correct? Now you have, suppose she met with a bus that is going with VB on her path in the same direction. Let's analyze this. In the same direction, she met with a bus, correct? So following is another bus with also the same speed VB, which is going to cover in how much time? In let's say you can see that in 30 minutes. All right. In the next 30 minutes, this second bus will come and cover this one, correct? So if at this point, if I'm going to apply the relative velocity, okay, if I find velocity of the bus with respect to the girl, correct? Let's say with respect to the girl, if I'm going to apply, what will that be? Velocity of bus minus velocity of girl will come, correct? So this will be equal to VB minus 60, we can actually write. And we know the separation between these two buses is D only, right? So we can actually find the relate this distance with the time, correct? So how do you relate this? You can write distance is nothing but yeah, you can write a D. What will that be equal to? Velocity is distance by displacement by time, correct? So distance is nothing but what? Velocity into time. How much it is? VB minus 60. That, see, I'm going to actually in the next step, I'll apply ratios only I'm going to take. So this velocity into time will be getting. What is the time here? In 30 minutes, the next bus is going to cover, correct? So we can write D is equal to what? VB minus 60. So the point is here, you need to keep in mind, relative velocity means what? You can now think like what? See, what is the advantage of taking relative velocity? See, this same problem where we have the bus going with the VB velocity and the girl moving with the V velocity in the same direction that we have seen. Relative velocity is given by VBG is equal to what? VB minus VG. Okay, what is the advantage of taking this problem in the relative case? It's like now, since with respect to girl, we are taking the velocity of girl, now you can take it like girl is at rest, right? Girl is at rest, you can take. And the bus is like going with what speed? The relative velocity speed. That is velocity of bus with respect to girl. That you can take it as what? VB minus VS. And what is the separation between them? D. Already we have actually taken. So that is how we wrote this equation. D is equal to what? VB minus VS into 30. This is one relation that we can use in this. Correct. At the same time, in the case of in the opposite direction, if you are taking, correct. Let's see the buses that are passing in the opposite direction. Here, what is the situation? We have the girl going with velocity v. There is a bus. She met with a bus. Suppose, okay. She a bus passed her. Suppose with velocity vb we are taking, correct. Now, at a d distance, we have the next bus that is going to pass her, correct? So again with the velocity vb only, right? So the second bus now, if you are seeing, right? The same way, if you are going to analyze, we can find actually the distance d and the time relation you can write here. The velocity of the, here I'll find, suppose, the velocity of the girl with respect to what bus. What is the velocity of girl with respect to bus here? Velocity, either whichever you want, you can actually take velocity of, let's write it velocity of bus with respect to girl only then. Okay, so velocity of the bus with respect to girl. In the second case, if you are going to write, what will it be? You can write it as velocity of bus minus, here you have to take like what, since the girl is going in the opposite direction, I have to take it as what, minus 60 we need to take. So obviously in the second case, d, you can write it as equal to what? The relative velocity is now vb plus 60 it will become. So vb plus 60 into the time is what? After what time they meet? You can, it is given 10 minutes, right? So the second relation also we have got here. Now what we have to do? We have to solve these two equations, first and second equation. What is our first equation? D is equal to vb minus 60 into 30, and second equation vb plus 60 into 30. So you can equate between these two since both are equal to d, correct? So you can write right hand sides are same. So we can write VB minus 60 into 30. What is that equal to? VB plus 60 into what? 10 will come. How we simplify that? See, here is why this time that we have taken 30 and 10, it is in minutes. I didn't convert it because since actually it will get cancelled, there is no use, right? So I'm actually using it just like that. So we can write what? 3VB minus like what, 180, that is equal to what, VB plus 60 you'll be getting. 180, if I take the other side, you get 240. 180 plus 60, that is equal to what, 2VB you'll be getting. Or VB, we are going to get it as what, 240 divided by 2, which is nothing but 120. Since actually distances, we have it's the 60, the velocity of girl, we have taken as velocity of the girl, we took it as what, 60 kilometer per hour. So this will also be unit is nothing but kilometer per hour. So we have actually reached to our result. Actually, result is nothing but what, 4 only we'll be getting. But at the same point, we can actually continue the discussion and we can find the time period also. Are we getting it 15 minutes or not? We can actually take it. Okay, for that, what we can do, let's take suppose the second situation, right? In the same case of opposite direction, let's consider the motion of girl and the bus that is traveling in the opposite direction. The second equation that we had, what is that equal to? D is equal to what? VB plus 60 into what? 10. Correct? 10 is actually in minute. So what I'll do into seconds or R, let's convert into R. So D will be equal to VB is we have got what, 120 plus 60 into what? What is 10? This is 10 by 60 actually I have to write because in order to, this is actually in minute we have written. So this to R we need to convert. So what will happen here? 120 plus 60, which is nothing but 180 divided by 6 is what you're going to get. So you are going to get D is equal to what? 30 kilometer we'll be getting. Correct? So now we'll very easily, we can actually analyze this situation. 30 kilometer, you can see here the bus travels, right? 30 kilometer the bus travels. So the time, if you are saying that time interval of this bus, if you are taking, how you can find after a bus travels 30 kilometer with 120 kilometer per hour speed only, the next bus actually start. So T you can write it as equal to what, distance by velocity, which is nothing but 30 divided by 120. What you are going to get, 1 by 4 hour, which is nothing but what, 15 minutes is what we are going to get in this case. Okay, so that's how we get this solution in this case. So this is the 22nd question. A uniform rod of mass 20 kg and length 5 meter leans against a smooth vertical wall, making an angle 60-degree with it. The other end rests on a rough horizontal floor. The frictional force that the floor exert on the rod, how much it is the question. Okay. So what is that we are having here? We have a rough horizontal floor we are having. We have the wall and uh, this, what is that thing? Yeah, we have a leaning. What is leaning here? A uniform rod, yeah. So I thought it is a ladder. Okay. So anyway, so we have this rod, which is of length 5 meter, it is being told. This leans against the wall. It makes an angle 60-degree also with it. Correct? Right. So here, how to analyze this problem? See, what are the forces involved? Let's consider here. What and all are the forces? See, let's say this is the center of this rod. Its weight mg will be acting vertically downwards, correct? Through this. Right. Now, at the same point, there will be at the lowermost point of the road, if you are seeing. Why? See, it will apply a certain normal. See, this will experience a normal force, correct? Since the weight of this is acting, not the complete weight actually, its weight is acting on this, uh, or this weight is actually balanced by what N2. You can, if let's say at this point, normal reaction will act on this rod. How much is that? Let's say it is N2. I'm going to mark or N1 or whatever. I took this one. Okay, now at the lowermost, one more force will be acting, which one it will be? It will be the friction. How the friction will be acting? Friction will be acting like this in order not the rod to slide. Correct. At the same point, at the topmost point, since friction is not there, there will be normal reaction only by the wall on the rod that will be acting. That I'm going to take it as what? N1. These are the different forces that will be acting. Right. So here, obviously, the different forces, how do you balance? You can write it as equal to what? F that will be equal to N1, correct? F is equal to N1, you can actually write, right? And mg that will be equal to, can we write? No, let's write it. This one we can easily write. F is equal to what? N1, we can actually write in this case. Right. So how to find the frictional, what is the question here? To find the frictional force. Correct. So how to find that? Let's analyze this. Okay, what we are going to do, we consider the rotational equilibrium. Okay, the rotational equilibrium of the rod. What do you mean by rotational equilibrium? Let's say this point, that the lowermost point is O. With respect to that point, what is the since actually the rod is in equilibrium, right? We consider the rotational equilibrium of it. Rotational equilibrium means what? The net torque will be equal to what? Zero, correct? Now, what and all causes the torque basically? The frictional force and N2 is acting at the point O only. So they does not cause torque. We need to consider this mg and N1. They constitute basically the torques in the opposite direction, correct? So to find actually the torques due to mg and N1, what will be that? Let's make some analysis here. Okay, the perpendicular distances of this torque basically, how do you find that magnitude of that force into the perpendicular distance? Correct. So in the case of mg with respect to the point O, what is that perpendicular distance? If you mark here, this suppose like if I mark it as x1, that will be the perpendicular distance, right? With respect to what the point O, correct? You can see here. Now, at the same time, for N1, what is the perpendicular distance? This is the line of action of N1. So, this distance, we have to take it as what? If we take it as x2, that is the perpendicular distance of N1. Okay. So, in the case of M1, that perpendicular distance, if I'm taking x1, how much that will be equal to? If this is, see, the top angle is 60 degree, this angle will be what? 30 degree. Obviously, at O, the rod making angle will be what? 30 degree, right? So this perpendicular distance, if you want to find, correct, x1 for us to find, how to find x1? We know this distance will be obviously, it is actually exactly at the center, right? So this will be 2.5. So if I'm finding cos 30, what is cos 30 equal to? Cos 30 is nothing but x1, correct? X1 divided by x1 divided by that hypotenuse, correct? Which is nothing but 2.5. So you get x1. What is that equal to? X1 will be equal to 2.5 into cos 30 will come. Correct? And that is equal to 2.5 into root 3 by 2, which is nothing but 2.5 by 2, it is 1.25 root 3. Correct? That will be the distance that we'll be getting. Okay, since these are all in meters, x1, you can write it as what? 1.25, 1.25 root 3 meter. That is what you'll be getting. Now, at the same time, we need to find x2 also. How to find x2? If in the same complete full triangle, if I'm going to find, if I find the sine 30, what you're going to get? Sine 30 is nothing but x2 divided by 5. Complete, you can write. Hmm? So x2 will be giving you what 5. Sine 30 is nothing but what 1 by 2, which is nothing but what 2.5 meter. So x1 we have got it as equal to what 1.25 root 3 meter, and x2 we have got it as what 2.5 meter. Both these we got. Now let's solve this question. We find the rotational equilibrium. Okay. So the torque due to mg, that is balanced by what the torque due to n1. So the torque due to mg you can write it as equal to what mg into the perpendicular distance is nothing but what x1, and that will be equal to what the torque due to n1 into the perpendicular distance what x2. Okay. So to find f is nothing but what n1 only. So if I find the n1 itself, our problem will be solved. So to find n1, we are doing this. So n1 is equal to what mg into x1 by x2. Correct. So what is the mass? Mass is nothing but 20. You can take g as 10 into what is x1? X1 is nothing but 1.25 into root 3. Correct. You want the answer also in root 3. So let's keep root 3 there. Divided by this is nothing but 2.5. Correct. X2 is 2.5. So here you can see 1.25 into 2 is what 2.5 is. Right. So here this 2 will go in this. It will give you 10. So you'll be getting the answer what 10 into 10, 100. 100 root 3 Newton is what you'll be getting as what N1. And we already have what this one. F is nothing but equal to what N1. So your answer will be what 100 root 3 Newton. And that will be the answer for this 100 root 3 Newton. So here is the 23rd question. In an oscillating spring mass system, a spring is connected to a box filled with sand. As the box oscillates, sand leaks slowly out of the box vertically so that average angular frequency omega and average amplitude A of the system changes with the time t. Which one of the following options schematically depicts these changes correctly is the question here. Okay, so let's see how to solve this question. Yeah, what is the system we are having here? We have a spring. Yeah, so here we have a spring mass system, correct? And this mass is actually the box that is filled with what sand. Now this is hanging. So this is executing what oscillations. Now what is the thing? Think of like there is a small hole in this. So the sand is suppose leaking out of this. Right. So as the sand leaks, what will happen? There are two things that will be happening. How it will affect the omega angular frequency, and you also need to see how actually it will affect what uh, the what is it the amplitude also. Okay, so what is our relation? Basically time period. If I'm going to find omega is related to time period, right? So t you can write it as equal to what time period for this oscillation is what if k is the spring constant and m is the mass. T is nothing but what 2 pi root over m by k. Correct. Okay. So one thing you can note here, the amplitude, right? Amplitude of oscillation basically what it depends on. Amplitude of oscillation, it depends basically on what the energy. Energy you can write as equal to what half k x square. You can actually write in this case, correct? Whatever x is the displacement you're providing from the mean portion, what is the displacement that you're providing, correct? Energy, basically like this you can write. But this k, it is basically depending on, see, if you write this mass mg, that will be equal to what kx naught, you can actually write, correct? Where equilibrium, from the natural length of the spring, how much it comes down, that is this length that I'm marking. So if suppose you can see as the sand leaks out, the mass basically decreases. What will be happening? The spring constant decreases. Okay. So that is one point that you need to see. So the spring constant, what will be happening? The spring constant will be decreasing. So because of it, since spring constant decreases, the energy leaks basically, correct? You can tell like the sand actually, the leaking sand actually carries away the energy, correct? So because of this, what you can tell basically, the amplitude basically what will be happening? It will be decreasing. You can actually write. Correct. Now, here, how actually what is angular frequency relation we need? How we can write this? See, time period is also equal to what 2 pi by omega. So, omega, how is it related here? See, you can write this relation 2 pi by omega, that is equal to what? 2 pi root over m by k relation that you're having. Correct. So here, how the mass relation and omega, you can see here very clearly. What is that? Omega is inversely proportional to what? Mass. Correct. So as the mass decreases, omega will be increasing. That's what will be happening. So what we are seeing here, amplitude decreases, omega increases. So the correct option, which one it will be? Omega increasing and amplitude decreasing. Option 2 only will be the correct answer for this. Question number 24. A balloon is made up of a material of surface tension S and its inflation outlet from where gas is filled in it has its area A. It is filled with a gas of density rho and takes a spherical shape of radius capital R. When the gas is allowed to flow freely out of it, its radius r changes from r to 0 in time capital T. If the speed v of r of a gas coming out of the gas coming out of the balloon depends on r as r to the power a, then t square proportional to s to the power alpha, a to the power beta, rho to the power gamma, and r to the power delta. Then what are the values of a, alpha, beta, gamma, and delta is what we need to find here. Okay. See, I'll start actually the problem with this, correct? With the given relation only. What is that? T is, we have this relation T that is proportional to what? S to the power alpha, A to the power beta, rho to the power gamma, and R to the power delta, correct? This is the given relation. What is S here? The surface tension. So suppose if I balance dimensionally, if I'm going to consider in this problem, basically two things that we are going to apply. Okay, this is actually a mixed concept question where we apply the dimensional analysis and one more thing that is going to come up. Let's see what it is. Okay, so here if I apply the dimensional analysis, left side it is nothing but what? T is capital T is nothing but time only. So T to the power 1 you can write. Correct. Now, surface tension, what is the dimension of surface tension? Surface tension is nothing but what? Force per unit length, correct? Force per unit length only it is, right? So, its dimension, what it will be? Forces mlt to the power minus 2, correct? Mlt to the power minus 2 because mass into acceleration divided by length will be coming. So here you can write this will be equal to what? M uh, L to the power 0 only, no? Because L and L this here you can see, right? So t to the power minus 2 whole to the power alpha. Area is nothing but what? L square to the power beta it will be coming. Density is what? Mass per unit volume, correct? The volume is L cube. So L to the power minus 3 it will be coming to the power gamma. R is nothing but L to the power. R is the radius, correct? So length only L to the power delta. So here if I club all those terms with the same powers, I mean mass together, I mean like for mass, if I club all these things together, you get what? M to the power alpha is there, then plus gamma is also there, right? What about L? L length to the power, you can see 2 beta, correct? Length to the power 2 beta is there, and minus 3 gamma plus delta, correct? This is how it is done. And you have also time, correct? We have time t that is to the power minus 2 alpha. This is also t to the power minus 2 alpha, m to the power alpha plus gamma, L to the power 2 beta minus 3 gamma plus delta, and t to the power this, correct? So left hand side and right hand side, the left hand side and the right hand side, if suppose if we compare, what is that you're going to get? The left hand side and right hand side we are comparing. So obviously we can write here a few things. What and all we can write. Since this left hand side, if I elaborately write, this is m to the power 0, L to the power 0, correct? So if I compare the power of mass, what am I going to get? Here you get alpha plus gamma, that is equal to what? 0. Okay, or we can do one thing. We can actually start with the time. Okay, so you can see here to the power, if I compare that of time, you can write minus 2 alpha, that is equal to what? 1. Or alpha, we get it as equal to what? Minus 1 by 2. So one thing we have already got. Correct? So now if I apply this to this equation, which we got by comparing the powers of mass. So you get gamma is equal to what? Minus alpha. which is nothing but what? Alpha is minus 1 by 2. So this will come 1 by 2. So gamma value also we got. Correct. So alpha, gamma value we got. See here, if the remaining terms that we are going to find out, correct, we will not be succeeding in that because we don't have further relations that we can connect between these. Because this next term that you can actually, if you compare that of the length, you'll be getting what? 2 beta minus 3 gamma plus delta. What you are going to get? You're going to get delta. The maximum relation you can reach up to is 2 beta plus delta, that is equal to what? 3 gamma, and you have gamma is 1 by 2, so you get 3 by 2. But again, here you can see there are two terms that are involved. We cannot proceed after this basically. So what we do here, one more relation is actually given, no? What is that? See, the speed of gas coming out of the balloon depend on R, correct? And what is that? This is proportional to R to the power A. Depends on R as R to the power A. So it's better we check on this way to find A. How, whether we'll be able to find A or not, let's find it out. Okay, now how do you do that? It is given that um, the gas is allowed to flow freely out of it. Its radius R changes from R to 0. In all these things that is given. See here, the balloon, if you are taking, you have the opening at this end of it, right? You can take basically the pressure inside. Okay, the pressure inside, you can take basically what? Yeah, the pressure inside basically equal to P if you are taking. We compare. See what we do here. It is we apply the Bernoulli's theorem. Okay, we apply Bernoulli's theorem here. Now, how do you apply Bernoulli's theorem here? We know of Bernoulli's theorem. What is that? At the same horizontal level, if you are taking, you can take like P plus half rho V square. This is equal to what? Constant. This is what we are going to do. Okay, so see here at the two different points like this. Okay, you may keep it like horizontal also. No issues, right? So at these 2 points, when you're comparing, this is the first point that I'm going to take, and this is the second point that I'm going to take. So we can write what? P1 plus half rho V1 square. What is that equal to? P2 plus half rho V2 square. We can actually write. And P plus what we can write? Half see here, basically this velocity will be zero, correct? Because the air is not moving. So here I'm taking this as zero plus P2, what you can write this equal to? P2, we can write it as equal to what? Zero, correct? Outside pressure. Let's comparing with the inside. The pressure difference will be large inside. So let's take the pressure outside is comparatively zero plus half rho V square. We can actually write here. So what we are getting here, half rho V square, that is equal to what? P you'll be getting. Right. So here, if I'm going to apply the pressure difference, okay, the pressure difference inside. So if you want, you can take like this also. If you take this is P2, this will become like what? P minus P2. And this pressure difference, you write it as equal to what? 2S by R. You can actually take like this. Okay. 2S by R. R small letter you are taking. So let's write this as small r basically. So what is that you'll be getting here? V square, that is equal to 4s divided by r rho you'll be getting, right? Or V is equal to root over 4s divided by r rho. You need to note that here very clearly you can see velocity is proportional to what? R to the power minus 1 by 2. And when this you compare with the V proportional to R to the power A, you get A is equal to what? Minus A is nothing but equal to what? Minus 1 by 2 also you'll be getting. So let's see here out of these whether we'll be able to get the answer here. What we have got just now, we have got alpha that is equal to, we have got alpha that is equal to what? Minus 1 by 2. Gamma is 1 by 2 and A is equal to minus 1 by 2. So whether we'll get the correct relation also or so you can see here. First option A is minus 1, A is 1 by 2. No. Second is A is equal to minus 1 by 2, correct? Alpha is minus 1 by 2, correct? And what about gamma is plus 1? Here it is minus that is given, so this is wrong. What about the third one? Third one, you can see A is equal to minus 1 by 2. Alpha is equal to what? Minus 1 by 2, correct? Beta, forget about it. Gamma is equal to what? Gamma is 1 by 2, correct? This can be possible. Okay, we need to confirm it with the fourth one. Fourth one, A is equal to 1 by 2 only. It's not minus 1 by 2. So obviously the third option will be the correct one. Okay, question number 25. Consider the diameter of a spherical object being measured with the help of a vernier calipers. Suppose it's a 10 vernier scale divisions are equal to its 9 main scale divisions. The least division in the main scale is 0.1 centimeter and the 0 of vernier scale is at 0.1 centimeter when the jaws of the vernier calipers are closed. If the main scale reading of the diameter is m is equal to 5 centimeter and the number of coinciding division is 8, the measured diameter after zero correction, how much it is the question? Okay, so first thing to note, very importantly, there is actually a correction that is coming here because the least division, this statement you can see, the least division in main scale is this, and zero of vernier is at this when the jaws of the vernier calipers are closed. That means there is a correction that is coming. You can see here x equal to plus, like the correction that is coming, it's a positive correction that is, sorry, it's a positive error that will be coming here. Error is you have to take it as what plus 0.1 centimeter. At the same time, correction, okay, you have to take it the opposite. It will be what minus 0.1 centimeter. You have to take the correction in this case. Okay, we'll do that correction at the end. Okay, after finding the final reading. Okay, I mean the true value. After that, we can find the final reading. So what is that we have got here? We have 10 VSD that is equal to what? 9 MSD. Correct? What we have got? 9 MSD that is equal to 10 VSD. So you can write obviously here 1 VSD. What will that be equal to? 1 vernier scale division is 9 by 10 main scale division. You can actually take. Correct? How do you find least count? Least count is nothing but 1 MSD minus 1 VSD for what? A vernier calipers. So this will be like 1 MSD minus 1 VSD is nothing but what? 9 by 10 MSD. So here you can write 1 minus 9 by 10 of what? Main scale division. So what is that? You'll be getting 10 minus 9, 1 by 10 MSD. It's given MSD is given. How much is MSD given? One main scale division. That is actually equal to what? One main scale is division is 0.1 centimeter. It is given. So you can write 1 by 10 into 0.1. You'll be getting as equal to what? 0.01 centimeter. That's what the least count of this that you get. So now easily you can find the true value. What is true value? The main scale reading that is given, main scale reading plus uh, vernier scale reading, VSR into LC, correct? You can write this as MSR plus VSR into what? LC. What is MSR? MSR we have got 5 centimeter. 5 plus VSR is vernier scale division, right? Vernier scale. So that is 8 into 0.01 centimeter. So you'll get 5 plus 0.08. So which is nothing but 5.08 centimeter. That's the true reading that you'll be getting. But at the same time, you need to see there is a correction. How much is the correction? Minus 0.1 centimeter. So the final reading we can write like this. Final reading will be 5.08 minus 0.1, which will be equal to what? 8 will be there, 10, 9, 4. 4.98 centimeter will be the answer for this. So 4.98. Option 3, 4.98 will be the answer.